Welcome to桂産直便. This is an interview program which brings you the hottest research sheets directly from Kyoto University's Graduate School of Engineering. This week we focus on moving vehicle type bridge inspection method. A bridge inspection method using vibration responses of a vehicle when it moves on a target bridge. In Japan, there are more than 700,000 bridges, and many of them are facing aging problems. Usually, visual inspections are used to check the health condition of these bridges. However, this visual inspection requires skilled engineers, and the shortage of skilled engineers who can carry out the inspection is an issue. Given this situation, Dr. Chan needs devoting himself to a moving vehicle type bridge inspection method. In this method, he uses moving vehicles' vibration responses to identify bridge properties. Sensors are installed on the inspection vehicle rather than on the target bridge. We invite Dr. Chan, Junior Associate Professor of the Department of Civil and Earth Resources Engineering, to talk about the challenges and the possibilities of his work. Hello, Chan Sensei. Could you introduce yourself?
Thank you very much for inviting me for the interview. This is Chang from the Department of Civil and Earth Resources Engineering. Today it's my great pleasure to receive this interview. Thank you very much.
Thank you. So your research focuses on a bridge inspection method using vibration responses of a vehicle. So could you explain the outline of your research and also how did you start your research?
Actually, this method is not very difficult to explain. This main idea is that we try to get the bridge vibration information from the vehicle responses. Our method is that we propose to put some sensors on the vehicles and to let the vehicles move on the target bridge we want to inspect, so that we can collect the vibration responses from the bridges and also from the vehicle itself. So we analyze the vehicle vibration responses and try to get the bridge information, the properties of the bridges, and also hopefully the damage information of the bridges, so that we can inspect the bridge if this is healthy or if this is damaged. So this is the outline of our study. Okay, so when do I start it and how do I start it? Actually, this topic was actually assigned by my supervisor when I was a PhD student. Truthfully speaking, it is the starting of this study. At the time, our research group is working on the so-called vehicle bridge interaction dynamics, vehicle and bridge interaction dynamics. That is our main study. But at the very beginning, we don't focus much on the vehicle vibrations. We focus much on the bridge vibrations. We care that how the bridge is vibrated under the vehicle loadings. But when we dip further and further, when we study more and more, we focus more on the vehicle vibrations, especially their interactions between vehicles and bridges. And we found that theoretically, the vehicle vibrations actually also receive some bridge vibrations simultaneously. So it attracts our interest. We think that if we can extract the bridge vibration information from the vehicle vibrations, it could be a very great idea. So that is the very beginning of the study.
My question is, how do you extract vibration information of bridge from the vibration responses of a vehicle?
The frequency domain analysis, that could be one method to extract the vibrations. Of course, first we have to measure the vehicle vibrations, so that we install some sensors, accelerometers, or some laser sensors on the vehicle. So that is the first step to measure. And then from the signals, the vibration signals. Of course, we can do some spectral analysis in the frequency domain, so that we can know what is the main frequency included in these vehicle vibrations. Or some further or some more advanced analysis techniques can also be used, like the modal analysis, like the time frequency domain analysis. Some more advanced signal processing techniques are also in our research focus.
Okay, so you have an experimental apparatus behind you, so we can see
Yes,
later.
that's right. Yes, no problem, no problem.
Okay, about the conventional method. So what is the issue of the conventional proposed method for bridge inspection?
Conventionally, and also now we have some regulations, some forced regulations. The Japanese government asked the bridge owners to inspect their bridges at least every 5 years. But the main method is to visually inspect. They call that visual inspections. The way is that they ask the engineers, some skilled engineer, to the site, to the bridge, and to check that this part is intact, that part is somehow damaged, that part is cracked. Some visual inspections like that. Okay, one bridge by one bridge, one component by one component. Okay, that is reliable, of course, but it is very time-consuming. It takes a lot of time, and also it takes a lot of engineers. So the problem is that now we don't have so many engineers, skillful engineers, to do this kind of inspection tasks. Okay, so now we also want to introduce some more also reliable method to aid this kind of inspection method. Okay, so also some researchers also propose to measure the bridges, to monitor the bridges by sensors, right? So they think that if we can put some sensors on the bridges, then we can measure, we can get the vibration data or some other physical quantities all the time. So we can monitor that this bridge now is vibrating normally, and sometimes that bridge is vibrating abnormally. Some problems there or something happened there, so that they also propose that probably we can do something like this. Okay, but these methods are all called direct method. Direct, because the sensor is directly installed on the bridge. Okay, so this kind of method is also quite reliable, but the problem is that when we install and when we want to maintain the sensors, usually we have to block the traffic. We have to block the traffic. We need to take the bridges all the time. Then when we block the traffic, usually it causes some complaints. the passengers, they may complain about that, and also it may cause some economic loss. Okay, so that could be a not so good point for the direct measurement method.
So what are the advantages of your method over the conventional proposed method?
Our method is not yet very powerful, not yet, but we try to solve some problems that are posed by the conventional method. Okay, so our method, we let the vehicle move on the bridge. So first, we don't have to stop. We don't have to stop the traffic. We can let the vehicle run without any stopping. So probably this may cause less complaints. So it's one point. And also, this method will be very mobile, because the vehicle, it can move to this bridge, then it can move to the next bridge very fast, very fast. So if we use the conventional method to put sensors on the bridges, if we want to uninstall the sensor and want to install the sensors to the other bridge, it may take a lot of effort. Okay, so the second point is that it's mobile. Okay, and the third point is that our method, the vehicles are moving non-stop on the bridge, so it can contact every point. It can collect the vibration responses from the bridge at many points, theoretically infinite many points, so that it can get a higher resolution in space. The spatial resolution will be higher than the direct measurement. Okay, so that would be the third advantage. So I think we also have many other minor advantages, but it will be quite good enough if we can solve the problems that we mentioned previously. Okay, talking about the outline of our study, our method is actually quite simple in concept. Okay, now maybe I can take this model vehicle and the model bridge for example. Our method is that we hope that we can get the vibration responses of the bridges. Actually, our target is to get the bridge vibrations, but our measurement, our system is put on the vehicle. We want to let the vehicle moving on the bridge. At the same time, we measure the vehicle vibration responses. Okay, when it moves on the bridge, actually it also receives the vibrations from the bridge. So we hope that if we can get the vehicle vibrations and we analyze the vibrations, we hope that we can get the bridge properties, like its frequency, like its mode shape, and also we hope that we can get some damage or health condition information from the bridges. We hope that we can move there and then we know that there are some damage there. The vehicle moved there, we found that there are some damage over there. Okay, so this is actually the main concept of our proposed method.
So the last question is, what is a vibration-based bridge damage detection for you?
The meaning of the vibration-based. Okay, to answer this question, probably I can start by the bridge vibrations. I feel like that the vibration, bridge vibrations, it's the heartbeat of the bridge. Okay, when we go to a doctor, with human beings, when we go to a doctor, the doctor usually they take our heartbeat, right? They can identify if you are healthy, if you are ill from our heartbeat. So the bridge vibration, to me, to our engineers, it also means something. It is the beat that can tell either this bridge is healthy or this bridge is damaged. Okay, that is the first meaning to me. So to take this heartbeat, the direct method, the vibration-based method, okay, it is what? To identify those damage from those vibration responses directly. Okay, they put the sensor on the bridge. That's very similar to the doctor. They put some scope on our heart so they can measure the heartbeat directly, right? More advanced. Now, in many other cases, if we cannot take the beat directly, okay, the indirect method, the so-called moving vehicle method, to me, it is very like that. We are taking the pulse. We are not taking the heartbeat directly, but we take the pulse. Actually, it is also equivalent to taking the heartbeat, but in an indirect way. So I think that to me, this method, the indirect method, the moving vehicle method, it's like taking the pulse of the bridge to identify if this is healthy or if this is damaged. Okay.
This time we introduced Dr. Chan's research on moving vehicle type bridge inspection method. This bridge inspection method can work along with a variety of other methods and is expected to contribute to ensure urban safety by preventing potential accidents. We look forward to seeing you at the next Katsura Sanjok Beam.